Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on Cambridge Lower Secondary Checkpoint for Science Paper 2 April 2023. Let's start. Question 1. This question's about a small mammal called a shrew. A. Look at the picture of two shrews from the same species. Each shrew has a different fur color. Fur color is controlled by genes. Write down the name of the chemical that makes up genes. The answer for this is quite straightforward. DNA, or you can write the full form, deoxyribonucleic acid. That's our answer. Part B, eagles feed on the shrews. Scientists sampled the population of the shrews living on the ground that's dark in color. This diagram shows the population of shrews over 2 years. Population for year 3 is not shown. An eagle feeds on the shrews during years 2 and 3. 1. The total population size of the shrews is the same during all 3 years. Predict the number of white shrews and grey shrews in year 3. Write your prediction on the table. We can see that in year 1, there's only one dark shrew and 4 of them are white. And in year 2, it becomes 2 dark and 3 white. That's because the ground is dark in color and these shrews won't be as easily visible as these, so the eagle can eat more white shrews. In year 3, this trend is likely to continue, so there'll be 3 dark shrews and 2 white. That's our answer. Part 2. Describe how natural selection explains the changes in numbers of white and grey shrews. In this case, there's a 3 marker and therefore we have to write 3 different points. The first point is that the grey shrews camouflage better with that dark ground than the white shrews do. This is point 1. Now point 2. Therefore, the eagle, which is the predator in this case, hunts more white shrews because they're more easily visible. Now, there's a higher number of black shrews in the population and the grey shrews, not black, sorry, the grey shrews, can reproduce to pass on their DNA to their offspring, increasing the population of grey shrews. That's our answer. Part 3. The scientists had to trap and release the shrews to get their results. Write down 2 safety precautions the scientists took when trapping and releasing the shrews. The first one is quite obvious. They had to wear gloves. That's because if you're handling the shoes with your hands, there could be some contaminants on the shoes and we would not know about it. So in order to not get infection from handling the shoes, the scientists have to wear gloves. And of course, the second one is to wear eye protection. They wore eye protection glasses. And the reason for this is that if the shrews get aggressive when the scientists are trying to trap the shrews, of course, they have to make sure they can see where the shrew is and make sure that their eyes do not get damaged by any of the shrew's aggression. That's our answer. Let's go to question 2. Look at the diagram showing part of the periodic table. A. The electronic structure of lithium is 2.1. Write down the electronic structure of chlorine. Chlorine is the 17th element in the periodic table. And the first shell always has 2 electrons maximum. The second one has a maximum of 8. The third also has a maximum of 8. So for 17, we can write as 2, and we have a full 8 shell. And then We have the next shell with 7. So the electronic structure is 2, 8, 7. Part B, write down the symbol for the atom which has 12 protons in its nucleus. This atom is just magnesium, the 12th atom, the 12th element, and the symbol is Mg. Part C, neon is in group 8 of the periodic table. Neon is an unreactive gas at room temperature. Argon is also in group 8, so just one property of argon. Well, group 8's most known property is that they are unreactive, so you can just write unreactive, or you can write another word for it, inert. These group 8 gases are also called inert gases for this reason. And of course, we can just write at room temperature. It's not really required, but then it is useful to specify. And especially since this question is already given that this is unreactive at room temperature, we can just write that. That's our answer. Let's go to question 3. Water moves through a plant. A. The table shows information about where the pathway of water goes into and out of a plant. Number 1 is the part where the water enters the plant. Number 5 is the part where water is lost from the plant. Complete the table by writing the numbers 1, 2, 3, 4, and 5 to show the pathway of water into and out of a plant. 1 has been done for you. The part of the plant and order is given. Leaf is the last one, the 5th one. Well, let's not start from here. Let's start from the first one, of course. So the water is absorbed into the plant through the root hair cells. And once they get into the root hair cells, they transfer it into the root xylem, where they will go up the stem xylem and then into the leaf xylem. And after that, they are transpired out of the leaf. Transpiration. This is, of course, if there's excess water, and that's how the water goes out of a plant. If the water that is used up in photosynthesis, of course, it does not exist anymore because it has been converted to a different substance entirely. In other words, glucose plus oxygen. So it won't be water anymore. That's why we don't count that. That's our answer. Part B. Plants lose water from the surface of their leaves. Write down the name of this process. We just spoke about this. Transpiration. This is how the water gets out of the leaf. Part C. A desert plant grows well due to its very waxy leaves. High carbon dioxide levels reduce wax production in these plants. Cars produce carbon dioxide. So just what happens to the populations of these desert plants going near a new road. If there's a new road, that means probably there'll be many cars on that road. And these cars will produce carbon dioxide very close to these desert plants. And therefore, it reduces the wax production in the plants. Because its leaves, the plant's leaves, lose their waxy covering, or lose the wax, that's how you can write. And thus, the plant's population decreases. It's not able to grow well. That's our answer. Let's go to question 4. This question is about waveforms. A. Look at the diagram of the waveform of a sound. Which letter shows the amplitude of the sound wave? Circle the correct answer. The amplitude is the maximum displacement between the original position of a wave and its crest or trough. So this distance is the amplitude, W. Part B. The waveform for the sound shows several waves. How many complete waves are there in 8 seconds of the waveform? We have 8 seconds here. And the number of complete waves we can see 1, 2, 3, and 4. So that's 4 complete waves. That was quite a simple question, wasn't it? That's not the end of it. Part C. The diagrams show how sound A interacts with sound B to make sound C. Describe how the waveform of sound A and the waveform of sound B interact at time is equal to 1 second. We can see that at time equals 1 second, These two waves both have crests. And because they both have crests, they will reinforce. And this reinforcing of sound waves causes the amplitude to go higher at that time. We can see that this amplitude is 4 units, although it used to be 2 for each of these. But now what happens at time equals 3 seconds? We can see that there's a crest for waveform A, and for sound B's waveform, it's a trell. Because these two are both 2 units, but then they're in opposite directions, this is up and this is downwards, they cancel out. You can just say they cancel. And this causes the amplitude at time equals 3 seconds for waveform C to be just 0. That's our answer. Let's go to question 5. Look at the diagram of the carbon cycle. A, write down the name of process A. Process A is how carbon dioxide goes from inside animals to the atmosphere, and this is of course respiration. We exhale carbon dioxide and this goes into the atmosphere. Part B, write down the name of process B. We can see that carbon dioxide in the atmosphere and sunlight come together into this process B. Process B, of course, is going to be photosynthesis then. Notice that this process B is inside the tree. Therefore, it has to happen inside the plant itself and not going to some other place in order to take place. Sunlight causes carbon dioxide to react with water to form glucose and oxygen. Let's go to part C. Write down one similarity between combustion and decomposition. We can see that combustion is this arrow here and decomposition is this one. Both of them end up releasing carbon dioxide to the atmosphere. So we can write that both release carbon dioxide. That's a similarity. Let's go to part D. Scientists believe that too much carbon dioxide in the atmosphere causes climate change. Describe 2 possible effects of climate change. Remember, these are effects and they are not causes. And therefore, we need to write what happens due to climate change. In this case, the cause is climate change, and we need to write the effect. Therefore, the first one, which is most obvious, due to climate change, global warming occurs, and this can be written as a point, but it's way too general, and therefore I think that would be better to write more specific. For example, glaciers melt, and therefore sea levels rise. So there's one point, and the other one, we can also be specific with this. We can write, for example, forest fires, wildfires, or you can write famine and droughts occur. And the one which I'll be writing, which also is a good point, is that there's more frequent extreme weather conditions. And this will be our answer. Let's go to question 6. Look at the data about some group 1 elements. A. Describe the trend in atomic radius as you go down group 1. We can see in the table that element melting point in degrees Celsius and atomic radius in picometers. This is an extremely small unit of measurement of length, so don't worry about it. We can still see that the numbers are increasing over here. And the trend as you go down group 1 in atomic radius, the atomic radius increases. That's the answer. Part B, predict the melting point of rubidium. We can see that the melting point decreases as we go down group 1. And we cannot make it if it decreases to make 63 here. This is a bit too close to potassium. We have to have it a bit further away. So for example, something like 40 should work. This is not an exact answer. You can write many different values. 20 to 45 degrees Celsius, any of these values could work. Part C, Sodium reacts with chlorine to make an ionic solid called sodium chloride. Sodium chloride has a melting point of 808 degrees Celsius. It has a structure and name this type of structure. Well, ionic solids which have high melting points usually have a lattice structure. And the most common example of lattice structure is sodium chloride, and therefore this will be our answer. Let's go to question 7. Write down the names of these electrical symbols. This one. This one is a buzzer. And the next one is a variable resistor. For the second one, writing resistor is not enough. You see this line going through the resistor symbol, then it has to be written variable. Otherwise, there's no mark for just resistor. That's our answer. Let's go to question 8. Here are some sentences about the collision theory for the formation of the moon. We have sentences from A to F. A. Put these sentences in the correct order to describe the collision theory. 2 have been done for you. Sentence E is in the 3rd position and sentence F is in the 5th position. Now we need to fill in the other 4 with the letters of A, B, C, D. Out of these 4, we can see that C is the first step for the collision theory. A collision occurred between the Earth and a small planet. And the small planet is often termed by scientists as Theia. Now the second one is going to be this caused very high temperatures and the Earth's outer layer melted. And due to that, the dense iron from the cores of both planets merged to create the Earth. And then these less dense rocks were ejected from this highly dense matter, and then they were captured by Earth's gravitational field as already given, and at the end, the less dense rock eventually merged together to form the moon. That's our answer. Part B. In 1969, astronauts went to the moon and collected rock samples. Describe how these moon rock samples provide evidence to support the collision theory. Well, there are a few points which you can write for this, but then the main thing is that the Earth's and Moon's rocks would have to be quite similar in properties. So, Earth's rocks and Moon's rocks had similar properties. You can also write Moon's rocks are less dense than Earth's rocks due to measurement, and that's our answer. Part C. Suggest why the density of the Earth is greater than the density of the Moon. Use ideas from the collision theory in your answer. We can see that in the collision theory, the dense iron from cores of both planets merged to create the Earth. So, this dense iron contributes a lot to the huge density of the Earth compared to the Moon. And the less dense rocks are those which are ejected and cooled and eventually formed the Moon. So we can say that dense iron from both planets merged to create the Earth. Or at least you can say Earth's core. And then the less dense rocks form the Moon. That's our answer. Let's go to question 9. Scientists estimate 1 million species of plants and animals are at risk of extinction. A. Which factors cause a species to become extinct? Take the 2 correct factors. Changes in seasons? Well, changes in seasons are normal and every animal can get through these. It's not really something that causes a species to become extinct. Changes to the environment over time. This is something that can cause extinction. For example, global warming can cause extinction of certain animals that live in polar regions or more cold regions, like polar bears or penguins, for example. It could cause a loss of habitat and therefore extinction. Increased reproduction, well, this does not cause extinction, it's the opposite. It causes growth of the animal's species. And then new diseases, of course, this causes extinction because in case there is a disease which affects a particular species, that species could be at risk of extinction. And new food sources, once again, this causes growth of the animal population, not extinction. Let's go to part B. Explain what is meant by the statement an animal is at risk of extinction. Use ideas about death rate and reproduction rate. We can see that there's only one mark, so it's not a lot that we need to write, it's just 1 point. And since they're already given that we need to use ideas about death and reproduction rates, we can just say that the death rate is higher than the reproduction rate. And if this trend continues, that means the animal will become extinct in a few years or even decades, millenniums as well. That's our answer. Let's go to question 10. Look at the list of metals in order of reactivity. The most reactive metal is at the top. A piece of copper is dipped into silver nitrate solution. Silver is made. A blue solution of copper nitrate is also made. A. What's the name of this type of reaction? Circle the correct answer. We can see that when copper is dipped into silver nitrate, it displaces the silver and it makes copper nitrate, and then the silver comes out. So this is called displacement reaction. Part B, write the word equation for this reaction. Well, we know that copper is dipped into silver nitrate solution. These are the reactants. The products are just silver and copper nitrate. So the word equation, copper plus silver nitrate, arrow, silver plus copper nitrate. That's our answer. Let's go to part. Look at the list of metals and solutions. Take the show if the metal reacts with the solution. Explain your answer. Copper plus iron nitrate. Well, we have two metals in this, copper and iron. If the metal, which is separate, has a higher reactivity than the metal which is inside the compound, in this case, if copper has greater reactivity than iron, then this reaction occurs. Then we tick it, otherwise we don't. And if we look, copper has lower reactivity than iron, so this reaction does not happen. Magnesium plus zinc nitrate. Magnesium has a higher reactivity than zinc, as we can see here. Therefore, we tick this. Silver plus magnesium nitrate. Silver has an extremely low reactivity, as we can see it's the lowest, and magnesium is way above it, so we don't tick that. Iron plus zinc nitrate. If we see, iron has a lower reactivity than zinc, so it cannot displace it. So this is the only one that can react with the solution. And explain your answer. As we said, magnesium has a higher reactivity than zinc. So we can just write this down. Magnesium has higher reactivity than zinc. This will be our answer. Let's go to question 11. Lilly investigates which type of insulation is best at reducing the transfer of thermal energy from hot water. Look at the diagram of Lily's experiment. We have the diagram here, and her results are also given in 3 different tables. A. The unit of temperature is missing from the tables. Write down a unit of temperature. We can see in the tables that it's just written temperature here, although there's no unit given, and that's what we need to write. The unit of temperature is just degrees Celsius. And you can write the symbol as well, which is degrees Celsius, like this. That's our answer. Let's go to part B. Calculate the decrease in temperature in 300 seconds for each beaker. For cardboard, the decrease in temperature is going to be 83 minus 65, which is 18. For newspaper, 85 minus 68 is 17. And for bubble wrap, 85 minus 73 is 12. That's our answer. Let's go to part C. Before the investigation, Lily predicts bubble wrap is the best insulator. Is your prediction correct? Explain your answer. If we go back to the results which he has, we can see that the temperature decreases the least in bubble wrap. we can see degrees in temperature is only 12, while for the others it's 18 and 17, which is greater. And insulation is supposed to stop heat from dissipating out of the beaker, and therefore this is correct. Bubble wrap is the best insulator. Her prediction's correct. And explain your answer. Of course, that's going to be because the decrease in temperature is the least for bubble wrap. We can just write that. Decrease in temperature is the least for bubble wrap. That's our answer. Part D. In one of Lily's results tables, there's an anomalous result. Circle the anomalous result in the table, give a reason for your answer. Let's go back and look at the tables. You might have noticed this at the start of the question, even before I started part A, but well, now we are anyway supposed to identify. Circle this, which is over here, temperature 67, and to explain our answer, we can see that the temperature has to decrease at every interval because there's no kind of heat source which is being given. There's no Bunsen burner which is placed below. There's nothing like that. And there's no kind of heat source, so the thermal energy will transfer from inside the beaker to outside. And therefore, it's not really possible to increase the temperature from 67 to 75 unless you have an external heat source coming in, which is obviously not being used in this experiment. Therefore, we can say that this 67 here does not fit the trend shown in the tables. Let's say these two, the temperature keeps decreasing, but for this one, it decreases, then increases, then continues decreasing. That's not supposed to be true. So this result, 67, does not fit the trend shown in the tables. That's the answer. Part E, Lily improves her investigation. Suggests two improvements Lily makes to her investigation. But if we go back to the tables, we can see that the temperature for cardboard, starting temperature is 83, but for the other two, it is 85. So to improve the investigation, of course, we have to make the starting temperature the same. This is one of the best points. Make the starting temperature the same. And as for the second point, we can see that this beaker is just left open. So there could be more heat dissipating out of here at some times, and there could be less heat dissipating out of the top in other times. So it's better to just keep a lid here so that no heat can dissipate through the mouth of the beaker, and we can test how effective the insulation actually is. So using a lid is another improvement which is possible. Use a lid on the mouth of the beaker. That's the answer. Let's go to question 12. Mike investigates the reaction between magnesium and dilute hydrochloric acid. Look at part of the equipment he uses. A. Write down the name of the equipment Mike uses to collect the gas and measure the volume of the gas. If you notice, this piece of equipment is not shown in the diagram here, but it is a gas syringe. It will be like a typical syringe, except it's fit for using gases as well. Something like this. And it'll be marked, of course, so we don't need to draw that, but we can write gas syringe. Part B. Mike measures the volume of gas made every 30 seconds until the reaction stops. Describe how Mike makes his results more reliable. Well, to make results more reliable, of course, the simplest thing to do is repeating the experiment. Because his experiment is already quite improved already. It's already at its maximum accuracy, and therefore there's nothing really we can do to improve it even more unless we repeat it and make his results more reliable. Remember, the word is reliable and not more accurate or precise, so this is the best answer. Part C. Mike writes a risk assessment for his investigation. Write down one safety risk and describe how Mike reduces this risk. Well, the easiest thing we can think of is that safety risk is that dilute hydrochloric acid, no matter how diluted it is, it's still very corrosive. So, hydrochloric acid is corrosive, and how he reduces this risk, he can just wear gloves and eye protection. That shields his hands, which are going to be handling the hydrochloric acid and magnesium from corrosion, and it also shields his eyes in case the acid splashes. And that'll be our answer. With that, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.